Welcome to the lecture series of hydraulic structures, and this is session 4 of module 3. So, in this particular session, we'll learn how to dissipate the energy of water which is flowing from the upstream side to the downstream side through the spillways. So, this will have a tremendous energy, and this energy will cause cavitation or erosion or scoring of the downstream bed, which results in the failure of the dam or the any structures which is near to the dam, like pumping station or whatever it is. So we learn what is energy dissipator, what are the different types of energy dissipators. Let me share the content. Yeah. So energy dissipation devices. So you can see here, this is the water which is flowing from the upstream side to the downstream side through the spillway, and you can see a jump has been created like this. So if you don't create a jump, this jump will dissipate the energy. A jump has been created here. This is done by providing energy dissipators. A hydraulic jump is created to reduce the energy of the flowing water from upstream side to the downstream side. So the flood water discharging through the spillway has to flow down from a higher elevation at the reservoir surface level to a lower elevation at the natural river level on the downstream side. So there's a difference in height. It has to fall from a higher elevation to a lower elevation. Therefore, the high velocity of flow has to dissipate the energy. So it has to, the water velocity of flow has to be reduced, its energy has to be reduced. So arrangements provided to dissipate this energy are called as energy dissipators. So energy dissipators are required to prevent the river surface from getting dangerously scalded by the impact of the falling water. So the bed of the river surface will get scored. So that has to be avoided by providing energy dissipators. It is necessary not only to protect the riverbed and banks from erosion, it should be ensured that the dam itself and the adjoining structures like powerhouse, canal are not undermined by the high velocity of flow. It is not necessary only to think about the riverbed and banks. You have to see that the adjoining structures like powerhouse, canal, and others are also saved from this scoring of bed. Energy dissipation can be achieved by the two ways. One is by developing a hydraulic jump. So I told you in the first picture only, I showed you that we can create a hydraulic jump to reduce the energy dissipation. The other one is by directing the jet of water using deflector bucket. So we'll discuss about this later on. So a deflector bucket will be used. I'll show you. Anyway. So, so when the water flows from upstream side to the downstream side, so a hydraulic jump will be created like this at the bottom. So when the hydraulic jump is created, in this jump the energy get dissipated, and also here by directing the jet of water which is flowing by using a deflector bucket. So at the bottom of the spillway, a bucket like this will be provided. So here the water will get deflected like this and then flows, and again it will rotate like this. So this causes dissipation of energy. So we use deflector buckets at the bottom of the spillway like this. So this will be the shape of a bucket. So that is one way of reducing the energy or dissipating the energy. There are two ways: by creating a hydraulic jump or by directing the jet of water by using a deflector bucket. So there are three types of energy dissipators. One is the stilling basin, the flip buckets, and the roller buckets. So we'll study one by one in detail. The first one is the stilling basin. When the hydraulic jump is used, stilling basins are used when hydraulic jump is used for dissipation. The basin is used for a head less than 50 meters. the difference in level between if this is a dam, the difference in level between the upstream and the downstream side. So if this is the downstream side, if this difference is less than 50 meters, this head, this we call it as head, less than 50 meters, then we will go in for, this is less than 50 meters, then we will go in for the stilling basins. Okay, the length of the apron is provided for the length of the jump. So here the apron will be provided. I'll show you in the figure. There are two types of aprons. Apron is nothing but a concrete structure. So if the water is flowing like this, then a jump is created at this point. An apron will be provided, a concrete apron will be provided in order to avoid scoring or undermining of the material in the river bed. There are two types of apron. One is the horizontal type and the other one is the inclined type. So you can see this is a horizontal apron and this is an inclined apron. So here water is falling from the spillway, and then this is the tailwater level, and here a jump has been created like this. So this is a horizontal apron. This is a horizontal apron, whereas there has been impact of water at this point, at this point. But when in an inclined apron, there will also be some impact at this point, but the intensity of the impact will be less in case of inclined apron. And this is the stilling basin. This is a stilling basin. So here it reduces the velocity of flow of the water which is flowing from the upstream side to the downstream side. So this is the stilling basin which is in the apron. This is called as the end sill, and this portion is also called as the end sill. Here the water is what the velocity of the water gets reduced in this pool in the stilling basin. So there are two types of aprons which is provided for the stilling basin. One is horizontal type and one is inclined type. In the inclined type, the impact of the waterfall will be less compared to that for the horizontal apron. Flip buckets. And these are suitable when tail water depth is low. I'll show you in the diagram when the tail water depth is low. See here, this is the tail water. The tail water depth is low somewhere here. So here the bucket is provided. A bucket shaped curve is provided here, and this will flip the water and causes a hydraulic jump like this. This will flip the water. This is the bucket. This is called as a flip bucket. It will flip and then causes a jump, and it will fall into the pool which is this side where there is the tailwater. When the tailwater level is low, then we provide what is called as flip bucket. So if the tailwater is low, we can create a jump. We can create a jump. If the tailwater level is high like this, we cannot create a hydraulic jump, and then so flip buckets are not used when the tailwater level is high because we cannot create a jump. So then we use what is called roller buckets, which we will discuss in the next class. So you can see here the water which is flowing down from the upstream side because of the bucket here. So hydraulic jump is created and the tailwater level is much below here, much below here. So energy gets dissipated here. Energy gets dissipated. So you can see it is suitable for sites where tailwater depth is low, and if there is a rock in the downstream area and is good in resisting the erosion, so it will directly fall into the tailwater where the rock in the downstream side, there is rock in the downstream side and it is good in resisting the erosion. Plunge pool may be provided for controlled erosion in the desired location. So if at all this rock is not available, then a plunge pool may be provided. A small amount of energy is dissipated by the internal turbulence and the shearing action of the surround air. And most of the energy is dissipated in the plunge pool. So you can see that there is area in between the jump, below the jump. So here also some energy gets reduced because of the turbulence created here. Because of the turbulence created here, some energy is reduced at this junction. So this is the advantage of flip buckets. Then the last one is the roller bucket. So this is also an example of a flip bucket. You can see water flowing through the dam. This is the upstream side where there is a reservoir and the water is flowing from the spillways, and then a jump has been created like this. Hydraulic jump is being created by providing flip buckets. Then we will see what is roller bucket. See, when the tailwater level is high, so here the level is high, so you cannot create a jump. So here some more depth is provided here. So there the shape is something like this, so it will jump, the water will jump, whereas here the shape is like this in case of roller bucket, because there is water above, the tailwater level is high. So when the shape is like this, when the shape of the bucket is like this, so water will they turbulate in this direction, that is in anti-clockwise direction, and again it flows out and again it will turn in clockwise direction like this. So therefore it is called as a roller bucket. So some depth is required to create a hydraulic jump. Okay, if the downstream depth is greater than required to create a hydraulic jump, then we go in for roller bucket, because we cannot create a hydraulic jump when the depth is more. Therefore, we go in for a roller bucket, and the dissipation is caused mainly by two rollers. I told you there is one roller here. This is in anti-clockwise direction, and this is in clockwise direction. So two rollers counterclockwise direction near the water surface and clockwise direction on the channel bottom in the downstream bucket. So this rotation will dissipate the energy. So in brief, so we discussed what is energy dissipators. Energy dissipators are required to reduce the energy of the water flowing from the upstream side to the downstream side of the dam, where it will have because of the difference in elevation, there will be velocity will be high and energy will be high. This energy has to be reduced, otherwise it causes scoring or caviation of the downstream bed. Not only that, and it will damage the river banks and also the structures near the river banks like pump house or canals. So it will, and also the dams, it will damage the dams. So there are three types of energy dissipator we discussed. One is the stilling basin, the other one is the flip buckets, and the third one is the roller bucket. Stilling basins are used when hydraulic jump is created. When the hydraulic jump is created, so at the end of the fall of water, a stilling basin is provided which will reduce the velocity of flow, thereby reduce by when the water flows onto the stilling basin, the energy gets dissipated. The second one is a flip bucket. So this flip bucket will flip the water and then create an hydraulic jump. And where the water falls, an apron is provided. So sometimes horizontal apron is provided. Sometimes an inclined apron is provided. Inclined apron is provided. So on an inclined apron, the the impact of water will be less compared to that of what impact of water on a horizontal basin. And the third one is a roller bucket. Here there will be there will be turbulence of water in clockwise and in anti-clockwise direction, which will dissipate the energy. This is used when the tail water level is high. When the tail water level is low, then we go in for a flipped bucket. So this is all about energy dissipators, and thank you for listening.